For almost a century, humanity has imagined the universe as the ultimate frontier, an endless ocean waiting to be crossed. And according to modern physics, there doesn't seem to be anything stopping us. The laws of relativity allow us to approach the speed of light. The equations of space-time permit wormholes. Some theories even suggest warp drives may be mathematically possible. So naturally, we assume that one day, advanced civilizations will spread across galaxies like explorers crossing oceans on Earth. But there's a strange problem hiding inside that assumption. The universe does not look explored. When astronomers scan the stars, they don't see giant interstellar empires. They don't see ancient civilizations reshaping galaxies. In fact, the cosmos appears almost completely silent. And that silence becomes deeply unsettling when you consider the scale of reality. There are hundreds of billions of stars in our galaxy alone. Many are billions of years older than the sun. Which means if deep space travel is truly possible, someone should already be here. Unless our understanding of space itself is incomplete. Because what if the universe only appears empty? What if interstellar travel is not prevented by engineering, but by physics hidden beneath the vacuum itself? An invisible resistance woven into the structure of reality. For centuries, humans imagined space as a perfect vacuum, an empty stage where planets, stars, and galaxies simply float. And according to classical physics, that assumption makes sense. A vacuum should contain nothing. No air, no friction, no resistance. Which means once a spacecraft accelerates in deep space, it should continue moving almost forever. But modern astronomy has uncovered something deeply strange. When scientists observe galaxies, the visible matter alone cannot explain their motion. Galaxies rotate too fast. Stars move as if they are trapped inside an invisible gravitational structure. Something unseen is there, and we call it dark matter. Usually, dark matter is described as missing mass, an invisible substance responsible for most of the universe's gravity. But that description may actually hide something much more disturbing. Because what if dark matter is not simply matter? What if it behaves more like a cosmic medium, an invisible ocean filling galaxies? Right now, as Earth moves through the Milky Way, we may already be drifting through enormous streams of dark matter without realizing it. And on human scales, its effects may be almost impossible to notice. But interstellar travel changes the equation completely. At relativistic speeds, even tiny interactions become catastrophic. A spacecraft moving near the speed of light could begin colliding with trillions of invisible quantum particles. Not enough to stop it instantly, but enough to create drag. A subtle resistance hidden inside space-time itself. And unlike air resistance on Earth, this drag would grow stronger the faster you travel, meaning the universe may contain a hidden speed limit beyond relativity. Not because engines fail, but because space itself is not truly empty. But quantum physics tells a very different story. At microscopic scales, empty space may not actually be empty at all. Quantum field theory suggests that even a vacuum is filled with fluctuations. Tiny particles appearing and disappearing constantly. Invisible energy vibrating beneath reality itself. Normally, these fluctuations are so small that they barely matter. But near the speed of light, the situation could become completely different. Imagine a spacecraft moving through deep space at relativistic velocity. From the ship's perspective, those tiny quantum fluctuations may no longer behave like harmless background noise. Instead, they could begin acting like collisions. Not ordinary collisions with atoms, but interactions with the quantum structure of space-time itself. And if dark matter also fills galaxies like an invisible field, the effect may become even stronger. The faster the spacecraft moves, the more violently it interacts with these hidden structures, which creates a terrifying possibility. Resistance that does not grow linearly, but exponentially. At first, the drag would be almost undetectable. Then, suddenly, beyond some critical velocity, energy loss could skyrocket. A civilization might build larger engines, more powerful reactors, even antimatter propulsion, only to discover that the universe itself behaves like an invisible wall. Not because relativity failed, but because the vacuum was never truly empty to begin with. According to Einstein's relativity, empty space has a very strange property. It does not slow you down. If a spacecraft were placed in a perfect vacuum and accelerated forward, there would be almost nothing to stop it. No air resistance, no friction, no drag. And this idea sits at the foundation of modern space travel. The only real obstacle, according to conventional physics, is energy. Because as an object approaches the speed of light, its relativistic energy increases dramatically. But notice something important. Relativity never says space pushes back like a physical medium. It only says acceleration becomes harder because energy requirements explode. In other words, the vacuum itself is still assumed to be empty.
At first, the problem seems manageable. If invisible quantum resistance exists, then an advanced civilization would simply build larger engines. More fuel, more energy, more power. That has always been the human solution. When ships faced stronger oceans, we built bigger ships. When aircraft hit the sound barrier, we built stronger engines. So naturally, we assume interstellar travel is just another engineering challenge. But physics may not work that way. Because if the vacuum itself resists motion, then adding more energy may actually make the problem worse. Imagine a spacecraft traveling between stars at relativistic speed. As velocity increases, its interaction with dark matter fields and quantum fluctuations also increases. Not slowly, exponentially. Which means every additional percentage closer to light speed demands absurd amounts of energy, only for much of that energy to disappear into the vacuum itself, not lost through heat, not wasted through mechanical failure, but absorbed by space-time. The ship pushes harder, and the universe pushes back harder, until eventually propulsion enters a terrifying regime. A point where engines produce unimaginable power, yet acceleration barely changes at all. Like revving a rocket engine while trapped inside wet concrete, or trying to outrun a black hole while glued to space-time itself. And beyond that threshold, interstellar travel may become physically meaningless. A civilization could harvest the energy of entire planets, build antimatter reactors, even construct Dyson-scale infrastructure, and still remain trapped inside its local stellar neighborhood. Not because technology failed, but because reality itself extracts an impossible price for extreme motion. And if that is true, then the silence of the cosmos suddenly makes sense. Advanced civilizations are not absent because intelligent life is rare. They may be absent because the universe behaves like a prison whose walls only appear when you try to leave.
In 1950, physicist Enrico Fermi asked a deceptively simple question. If intelligent life is common in the universe, where is everybody? Today, we call this the Fermi paradox. Because statistically, the galaxy should already be filled with ancient civilizations. The Milky Way contains hundreds of billions of stars. Many formed billions of years before our sun. which means some civilizations could, in theory, be millions of years more advanced than humanity. And on cosmic timescales, colonizing a galaxy should not take very long. Even slow-moving spacecraft could spread civilizations star by star. So, according to conventional thinking, the night sky should look alive. We should see megastructures, artificial energy signatures, evidence of galaxy-wide engineering. But we don't. The universe appears almost perfectly silent. And maybe the reason is not biological. Maybe civilizations survive. Maybe they become highly advanced. Maybe they even conquer their own solar systems. But when they try to cross interstellar distances, physics stops them. Because if relativistic travel triggers catastrophic quantum resistance, then every civilization eventually hits the same invisible wall. The faster they move, the more energy disappears into space-time itself. Interstellar expansion becomes exponentially expensive. Not economically, physically. A civilization may spread to nearby stars slowly over thousands of years, but true galactic empires become impossible. The distances are simply too vast, the energy cost too extreme, the hidden drag too powerful. And suddenly, the Milky Way transforms from an open frontier into something much darker. An archipelago of isolated civilizations, each trapped inside tiny islands of stars, separated not by war, not by fear, but by the structure of the universe itself. Which means the silence of the cosmos may not be evidence that life is rare. It may be evidence that escape is impossible.
Human intuition was shaped on Earth, inside an atmosphere, inside gravity, inside a tiny corner of the cosmos where the laws of physics appear stable and familiar. And for most of human history, space looked simple. A giant emptiness. A silent vacuum separating worlds. Even modern physics inherited that assumption. Once you remove matter from a region of space, what remains is supposed to be nothing. Empty distance. But nature has a habit of changing its behavior when scale changes. Water looks smooth to the naked eye, until you examine it at the molecular level. Solid metal appears rigid, until quantum physics reveals that atoms are mostly empty space. Reality is often an illusion created by limited perspective. And the same may be true for the vacuum of space itself. Because on human scales, deep space behaves almost perfectly empty. Planets move freely. Light crosses billions of kilometers. Spacecraft drift without noticeable friction. So, naturally, civilizations conclude that the universe is open. But interstellar distances operate on scales humanity has never truly experienced. And at those scales, hidden structures may begin to emerge. Quantum fluctuations, dark matter fields, microscopic interactions woven into space-time itself. Effects so weak that they become invisible over short distances, yet overwhelming across light years. It would be like mistaking the surface of an ocean for solid ground because the waves were calm near the shore. Only after sailing far enough do you discover the storm beneath. And that possibility changes everything. Because if space only appears empty at small scales, then deep space travel may rest on a dangerous misunderstanding. Not a technological misunderstanding, a physical one. Humanity may be attempting to cross the galaxy using equations that only work locally. Like ancient sailors navigating an infinite ocean with maps designed for rivers. And if our understanding of the vacuum is incomplete, then the dream of unlimited expansion across the stars may not be a future waiting for us. It may be an illusion created by incomplete physics. For generations, humanity imagined its future among the stars,
A civilization expanding across the galaxy. New worlds, interstellar cities, entire human civilizations orbiting distant suns. And for a long time, science fiction treated that future as inevitable. All we needed was better technology. Better engines, better reactors, better spacecraft. But what if the real obstacle was never technological? What if the universe itself was designed to resist expansion? Not through violence, not through destruction, but through invisible physical limits hidden deep inside reality itself. Because throughout this journey, a terrifying pattern has emerged.
The vacuum may not be empty. Dark matter may behave like an invisible medium. Quantum fluctuations may create resistance at relativistic speeds. And together, these effects may form something extraordinary, a natural barrier against interstellar civilization. Not a wall you can see, a wall built into physics itself. Which means every advanced civilization in the universe could eventually discover the same horrifying truth. Beyond a certain point, expansion becomes impossible. No matter how intelligent you become, no matter how much energy you control, the universe extracts a price too great to pay. And suddenly, the silence of the cosmos no longer feels mysterious. It feels inevitable. Because civilizations may rise across the galaxy every million years. They may master artificial intelligence, harness antimatter, even reshape entire planets. Yet all of them remain trapped inside isolated islands of stars, alone, looking out into an unreachable universe. And if that idea is true, then humanity may never become a galactic species. Not because we failed, but because the cosmos was never built for unlimited travel to begin with. Which leads to one final, deeply unsettling possibility.